Hello, Keith Rucker at VintageMachinery.org. Well, guys, we've got a little project we're going to be working on today that I think you guys will find interesting. We're going to be doing this. This is actually for a viewer and friend of mine, Jack Coyne, who lives up in Ohio, asked me if I could help him out on this. We actually did a little horse trading. He traded me a magnetic compound sign plate to use over my surface grinder to do this job, so I need to get it knocked out. So what we've got, I tell you what, let me zoom you in here and I'll kind of show you what we got. All right, so basically what Jack sent me down was this piece of rod here, and this is 1 1/8" diameter. And he also sent me along a couple of pieces of bronze here and a gear. And here's what he wants us to do. So this is actually going to go into a table that he's making. I think it's like a dining room table or something like that. And he's got a mechanism designed for it that will, when you crank a crank, it's going to open up, expand the leaves out and open up, make the table larger. And this screw here, or this rod, which is going to become a screw, is going to be a key part of that. So what he wants me to do, this gear is going to kind of mount in the center of this and somehow link up, I'm not exactly sure. He wants about a 3-inch gap in here, and then threaded on either end, one side left hand, one side right hand, so that when you turn this, it'll be expanding in both directions basically. And the nuts, he actually wants me to make the nuts out of this bronze that'll go on here. So there'll be a nut on each side, left and right hand thread, and then thread this. He wants it done in Acme threads, and we're going to do it in 8 pitch. And no real great reason for 8 pitch other than that's what I had some inserts to cut. Quite honestly, he said he didn't really care what pitch it was. And anyway, so I've been thinking about how I want to go about doing this. You know, doing the left and right hand threads, the external threads, no big deal. I can do that very easily on the metal lathe. The key though is to when I'm doing this, I got to make sure everything fits. And so what I've decided to do is actually make the nuts first, just make them to spec, and then once I have the 2 nuts made, when I'm turning the rod, I can actually test fit the nut onto the rod so that I can basically make everything fit. You know, logic would probably say, hey, cut the external threads first and make the nuts to fit, but it's going to be hard for me to get this big long rod over into here and test the fit in the nuts. It's going to be easier to use the nut to test the fit on the rod. So anyway, that's what my game plan is going to be, is we're going to make the 2 nuts first. And let me talk a little bit about the specs on these Acme threads and how we're going to go about doing that. To do the Acme threads, you know, doing the external threads is no big deal, but cutting the internal threads, I need to figure out what size hole I need to drill in here for the threads that I'm cutting. And because 1 1/8", 8 threads per inch is not really what I'd call a standard size, there's nothing to say you can't do that. It wasn't something I could just real easily go out and look up. So I actually found on the internet, this is at Engineer's Edge website, they've got a little calculator that will calculate your Acme thread information for you based on the external thread diameter and your thread pitch. So I put in 1 1/8", which is 1.125, and 8 here, and it basically calculates a lot of these measurements for me. And from that, I was able to determine that the size of the hole I need to push through here is going to be basically 1 inch. The minor diameter, inch to 1 inch 6/1000 is kind of the min and max that it calculates for that. So we're probably just going to take a 1-inch drill bit, go through there, and that's going to be our starting size for the Acme threads. And then I can come in with a tool like this. I got to change my insert out. I've got a Acme insert for 8 threads per inch, and we'll just do internal threading on the nut. So anyway, that's kind of what we're doing now. As far as depth of cut, and this is going to be the thing that we're just going to go by spec. I was able to determine that it's pretty easy on Acme threads. The formula is half of the thread pitch plus 10 thousandths. So we'll just do it real quick here. So we got 1 divided by 8, because it's 8 threads per inch. So each pitch, the thread pitch is 0.125. We're going to divide that in half, 0.625, or 0.0625, excuse me, and then we're going to add 10 thousandths, so plus 0.010. So basically, once I punch the hole in here, or put that half or 1 inch diameter hole in there, we'll just come in with the internal threading bar, we'll touch off on it, and we'll feed in 72.5 thousandths. And I'll just use an indicator over on the lathe to measure that. And we should hopefully have a nut that is properly made. And then, like I said, we will cut our threads on the rod so that we have a good fit with the nut. So that's the game plan. Let's get over here on the lathe and start making some chips. I've got my piece of bronze here chucked up in the lathe. What I think I'm going to do is just go ahead, we're going to face this side off. That side's cut at a weird angle. I'm probably going to go ahead and drill the 1 inch hole through it, then we'll flip it around, face off the other side, and we'll be ready to start threading. So let's fire the lathe up and get in here and get this thing knocked out. Good now. I'm in here with my center drill. Let's get a hole started in the middle there. I think we'll start with a 1/2 inch drill. Just go ahead and push through this. All right, now we're going to go to a 1 inch drill bit. I've slowed my speed down a good bit here to get this through. And that drill bit's So I went down to a 3/4 inch drill bit to put another intermediate step in here. This seems to be working a lot better. Going just straight up to 1 inch was just a little bit too much for it. I was having trouble with my drill bit slipping and my Morse taper shank. So anyway, we're gonna do a little intermediate cuts in there, which is what we probably should have done to begin with. Now let's move on up to our 1 inch and see if it'll cut. All right, we're through. So now I'm going to come over here. We're going to flip this part around. And we'll face the other side off flat and get this to a uniform thickness. And I'm going to have to do some measuring and decide what I want that to be. Let me first just get it trued up. final measurement here. So I need about 15 thousandths. All right, let's get our bar set up, the threading bar to set this up, and we'll cut some threads in here. All right, so let's talk about our setup here. We're going to do internal Acme threads. These are going to be the regular right-hand threads, so we'll be threading, feeding into the part. First off, my angle of my compound here, because Acme threads have a 29-degree angle in them rather than a 60-degree angle. What you want to do is you want to set your compound to half of that, so it'd be 14.5 degrees, rather than the 30 degrees or 29.5 that we normally set to for regular threads. Also, because we are doing internal threads, we're going to be cutting on a different edge than we normally do. So we're actually going to be cutting on this front leading edge of the cutter. So what I want to do is I want to make it where my compound is pulling back so that I'm making a nice cut all the way across there. So when you look at the direction that this compound is moving in and out, it's basically moving in and out on the angle on the back side here. So whenever we move in, we're taking a full cut on that front edge, okay? So it's, normally when we're doing external threads, the compound's at this angle. Internal threads, we're going to be at this angle. So anyway, that's got all that. I've got an indicator set up on here. I know from my measurements that we need to be making a cut that is, 72.5 thousandths deep is my depth of cut. And we're going to read that right off of that indicator. Now, why not just use your dial here? Well, the reason we don't use the dial is because it is on an angle. So if I move this back 5 degrees, in fact, let's just do that. I'm going to come over here. I'm going to zero this out here. We'll zero it out here. So I'm going to move this in 10 thousandths. Okay, according to my dial, I've moved 10 thousandths, but I've only moved 9 thousandths actual in. The reason is because I'm moving it in at an angle. So I'm actually on the hypotenuse of a triangle. Putting the indicator on here, I'm going to get a direct readout as to my actual depth that I'm feeding. And again, we're going to have to go 72.5 thousandths total depth on there. Now it's going to be a little bit funky because, we'll go in, we'll make our first cut, we'll go in, and then we'll back out, come in, go back to zero. I'm going to use my dial for that. But the bottom line is this will give me a good true readout of what I'm doing on my actual depth of cut. And then finally, I've got my thread dial down here. Hopefully you can see that in there. And we'll probably just go on any of the numbers. Technically on 8 threads, I could probably go on any line, but I like sticking to the numbered lines because that's going to work on either even or odd thread numbers. So anyway, we'll be watching that, and will be when we engage our half nut. So let's get in here and get this set up, and let's cut some threads. So first thing I'm going to do is just kind of come in here. We're going to feed in a little bit until we are touching. I'm cutting right there, just barely touching, and that's going to become my zero. So I'm going to zero my compound right here, and I'm just going to come around here to zero, and that way when I come in, I'm going to always come back to my zero. And the other thing I want to do is go ahead and zero my indicator, and I like having it up at the top. So I'm going to make a slight adjustment here. That's close enough. All right, we're at zero. So first pass here, I'm just going to take a couple of thou. and we're going to just basically make a scratch pass this first pass to see what our depth is, or make sure we're on 8 threads per inch. We should be over here according to my setup, so let's go in here and make a test cut and see. We'll engage there on the 1. We're going to let that cut all the way through, come out the other end, and then we will come up and back out. And then I will go back to 0 over here, and we're back to where we were on that 2/1000 cut. Let me get a thread gauge, and we'll check our 8 threads. All right, I've got a Acme thread gauge here, and I'm just sticking it down in here and looking at my threads, and they are indeed on 8 threads per inch, so we're good to go there. All right, we're just gonna come in here and whittle away at this thing. Wait for my 2 to come around right here. We will engage the half nut there and make our next pass. All right, we're all the way through. Back to 0. All right, continuing on here, we'll take about another 5/1000 feet on there. All right, here we go. So I got about another 3 or 4 thousandths depth to cut. Engage. All right, come out. Back to 0 on my dial. And let's take another 3 thousandths. And just rinse and repeat from here, guys. All right, we're almost to 70. Notice the spring back here. That's the reason you make spring passes, particularly when you got a boring bar. That's just from tool pressure, but we will make sure that our final pass, we do a couple of light passes to clean it up at the end. All right, so 72.5 is what we're after. 71, 72, and there's about a half, so I'm just going to leave it right there. And let's wait on this number to come back around. I go back to 0 on my dial. We're back at 72.5 here roughly. So I'm just going to make some spring passes now until we quit having any tool pressure, so that we make sure we get that last couple of thousandths in there. I'm happy with that, guys. We should have our first Acme nut all ready ready to go. So we can use this as a gauge now when we're cutting our threads.